All right, here we're going to go over the problems that were in Solving Equations Exit Ticket 1 and give you a chance to earn back some missed points if you did not achieve mastery on that assignment. And mastery would be an 80%. So here, question A said 12 equals n minus 2. So when we're doing these, we're solving the equations for the variable. So we want to isolate the variable or get that n on one side of the equation by itself. To do this, we need to use our inverse operations. So remember, for our inverse operations, those are operations that undo each other. So adding and subtracting, those are inverse operations. To undo adding, you subtract. To undo subtraction, you add. And then multiplication, which I guess I'll write as an x for now, and division, those are inverse operations, and they undo each other. To undo multiplying, you divide. To undo dividing, you multiply. So if we look here at this problem, remember we want to isolate the variable. We want to get this yellow n by itself. So the very first thing we need to do is figure out how we're going to move this minus 2 to the other side of the equation. And to do that, we're going to look at our inverse operations. To undo subtracting 2, we need to add 2. So remember, whatever we do to one side of the equation, we have to do the other. So we're going to add 2 to both sides of the equation. When you're working on these, make sure you have Desmos up and open and that you're using it. Desmos is a tool and it will help us. So here, 12 plus 2 is going to give us 14. And then over here, the whole reason that we added 2 to both sides was to move that 2 over to get rid of it. So these 2's kind of cancel out, they go away. And we're just left with n. Now we are done. We have solved the equation because we got n on one side of the equal sign by itself and a value for n on the other side. So we successfully isolated the variable. And now on your own, you're going to try this problem. It's very similar to question A. So if you get stuck, rewatch that part of the video. You're going to write this question down on paper and solve it now, and then put your answer right here. All right, in problem B, again, we're solving the equations. We want to isolate the variable. So in this case, our variable is k. We want to get k on one side of that equation by itself. So 5 equals k divided by 4. Remember, we use that fraction bar to represent division. So if we think back to our inverse operations, we undo dividing by multiplying, or the inverse of divide is multiply. So here, to undo dividing by 4, we need to multiply both sides of the equation by 4. So when we do that on the left-hand side here, 4 times 5 is 20. On the right-hand side, when we multiply, oops, let me get my pen here. Okay, that didn't work. But on the right-hand side, when we are multiplying, 4 times k over 4, these 4's here, those make a big 1. So then we have just 1k left on the right. So now we have 20 is equal to k. And we're done because k is on one side of the equal sign by itself. We have isolated the variable. All right, so now here's one that you're going to try on your own. Again, it's very similar to problem B that we just did. So if you need to, go back and rewatch that segment of the video, and then you're going to put the answer right here. All right, for question C, it says 3x equals negative 60. Now remember, when we have that 3x, that's like 3 times x. So we need to ask ourselves, what is the inverse, or how do we undo multiplying by 3? And to undo multiplying, you divide. So we're going to divide both sides of the equation by 3. When we do that here, 3x divided by 3, these 3's make a big 1. So we're just left with 1x on the left-hand side, which we typically just write as x. We don't need to put that coefficient of 1 there. And then on the right-hand side, you're going to use Desmos to actually do negative 60 divided by 3. When you type that in, you get negative 20. And again, now we're done because we've isolated the variable. We've got an x on one side of the equal sign by itself. So just like the other two, now you have a problem that's similar to question C that we just did together. So you're going to answer this question right now. All right, question D, negative 148 is equal to 2 plus 10m. So the first three were kind of just one-step equations. Now we're getting into two-step equations. But the goal is the same. We still want to isolate the variable, or get the letter on one side of the equal sign by itself. So if we look at this, negative 148 equals 2 plus 10m. We want to get m by itself. So the first thing we need to do is figure out how to take this 2 and move it to the other side of our equation. Now that's a positive 2, it's a plus 2. So to undo adding 2, we're going to subtract 2. Because remember, the inverse of add is subtract. So here on the left-hand side, we have negative 148 minus 2. Again, remember, you can use Desmos or a handheld calculator for that. When you do that, you get negative 150. Oops, oh, okay. You get negative 150 is equal to, on the right-hand side, we had $2 and we gave away $2, so they cancel out. We have no dollars left. But we do have this 10m that we have to bring down. We can't just forget it because it doesn't just disappear. So now we have negative 150 equals 10m. Remember, this 10m is like 10 times m. We just don't put that multiplication symbol in between there. So back to our inverse operations. To undo multiplying by 10, we are going to divide both sides by 10. So we're going to divide both sides by 10. When we do that, on the left, negative 150 divided by 10. Again, that's something you can just type in Desmos. We get negative 15 there is equal to, well, 10 over 10 just makes a big giant 1. So we're left with negative 15 is equal to m. And now we're done because we have successfully isolated the variable. We got m on one side of the equal sign by itself. So here's one for you to try. Negative 100 equals 10 plus 9m. Again, very similar to the problem we just went over. So if you need to, rewatch that section of the video, and then you're going to answer this question right here. All right, question E, we have 22 is equal to negative 10 minus 8x. So again, the goal is to get the variable on one side of the equation by itself. So we want to get just 1x over here on the right. To do that, let's first take this negative 10 and we need to figure out how to move it to the other side of the equal sign. Looking at our inverse operations, to undo subtracting, we add. So we're going to add 10 to both sides of the equal sign. Because remember, whatever you do to one side of the equation, you have to do to the other. When we do that, we get that 32 is equal to negative 8x. Because remember, since we had a minus 10 and we added it to both sides, they just go away. We said, oh, good, I moved that. We successfully moved this. All right, so now we have 32 equals negative 8x. Remember, that's negative 8 times x. So to undo multiplying by negative 8, we're going to divide by negative 8 on both sides. When we do that, remember, negative 8 over negative 8 makes a big giant 1. So we are left with negative 4 is equal to x. And now you're going to solve 44 equals negative 6 minus 10x and put your answer right here. All right, the last question here, letter F, negative 8n minus 2n equals 20. Here, on the left-hand side of our equal sign, negative 8n minus 2n. These are like terms because they both have the same variable. So when we have like terms on the same side of the equal sign, we need to combine them. So negative 8n minus 2n would give us negative 10n is equal to 20 because we need to bring down that right-hand side of the equation. Remember, negative 10n, that's like negative 10 times n. We just don't write the multiplication symbol in there. So to undo multiplying by negative 10, we're going to divide both sides by negative 10. When we do that, negative 10 over negative 10 makes a big giant 1. So we're just left with 1n, which remember we just write as n is equal to, and then 20 divided by negative 10 will give us negative 2. Now here's the last one for you to try. Negative 7n minus 4n equals 77. Again, if you need to look back at the section of the video that we just completed, please do that and then put your answer right here.